LIDAR, which stands for Light Detection and Ranging, is a technology used to determine ranges with lasers and a sensor measuring the time for the light to return after being reflected. LIDAR therefore makes it easier to analyze the surface of wide areas and collect large amounts of data about both natural and man-made environments, which is often impossible otherwise. This information collected with LIDAR is very valuable and has multiple applications in fields such as geology, military, archaeology, and many others. LIDAR technology was invented by a team of researchers led by Hughes Aircraft Company engineer David Bates in the early 1960s. The team was working on developing a laser range-finding system for the US Air Force to use in their aircraft. Bates and his team discovered that by using a laser to measure distances, they could create images of objects and their surroundings, which eventually led to the creation and development of LIDAR technology. In the history, this technology was notably used to map the lunar soil from orbit during the Apollo 15 mission in 1971. Besides, LIDAR is of course useful on Earth to study landforms, predict landslide events, and serve as an early warning system for flooding. It's a powerful method to visualize tree structures and heights in forests, which is very interesting to evaluate their evolution. LIDAR can help to study large-scale ecological issues. For example, it is used to estimate ecological metrics such as vegetation density, which is directly related to carbon cycling and climate change. Also, as this technology peers through dense forests, it can easily detect what's underneath. LIDAR has thus helped to quickly explore Ciudad Perdida, an ancient city in Colombia, without damaging the jungle around it. LIDAR is also used in fields less related to the environment, such as crime scene analysis, autonomous cars, and augmented reality implementations.
How do the LiDAR works? First part, composition. The LiDAR is composed of different elements. A laser to scan the ground surfaces.
An airborne LIDAR system emits a laser from an aircraft that scans the ground. The light energy passes through the canopy and reflects off branches and leaves. Thus, the system receives more data and can model the interior of the trees.
Moreover, it's a green laser because it's the best color to be reflected on vegetation. A GPS to know the location of the plane at any time. An inertial movement unit, which is a device to register the tilt of the plane to take it into the calculus. And finally, a computer to receive the information and to stock the data acquired by the LiDAR. Now we will see how it receives those data. In the first step, the LiDAR emits a beam groundward, a beam which is reflected by obstacles like trees, bush, or mountain in all the direction, and so a direction which makes the LiDAR comes back to the capture. We can assume that this direction is parallel from the previous one because of the almost immediacy of the speed of light. But how could we get the height of obstacle with this technique? I said previously, the light is only almost immediate, so we can measure the time that the light takes to come back to the plane and deduce the distance between the obstacle and the plane. We get h, the distance between the plane and the obstacles, by multiplying the time measured by the curvature of light and divided by 2 because it makes the travel 2 times. And because we know the altitude of the plane with the GPS, this altitude minus h gives us the height of our obstacle.
But there is limits to this technology. First, area with high density of vegetation, like under the trees, it's a bit complicated to a plane to fly there, so we use drones to this kind of measure. Also, the accuracy of this system is about 200 points by meter to the square, so 1 point is equivalent to 70 centimeters to the square, which is not a very high level of precision, but it's still better than all the other systems.
The LIDAR system has many advantages over other mapping systems. Unlike a camera, LIDAR technology can be used day and night thanks to the active illumination sensor, and unlike the radar, it can distinguish two objects that are very close. In addition, LIDAR system makes it possible to know the distance, size, and volume of objects. Data can be collected quickly and with a high accuracy. LIDAR technology, unlike photogrammetry and surveying, has minimum human dependence, since most of the processes are automated. It is not affected by extreme weather and it can be used to map inaccessible and featureless areas. However, this technology has some cons. Indeed, a camera has a better resolution and this system is still very expensive. In addition, LIDAR pulses may be affected by heavy rains or low-hanging clouds because of the effects of refraction. When it is used on wetter surfaces or where the surface is not uniform, it may not return accurate data. For the seabed, because the water will affect the reflection of the pulses. LIDAR technology cannot work on altitudes higher than 2000 meters because the pulses will not be effective at this height and it is difficult to analyze very large amounts of data. To conclude, the LIDAR technology is constantly evolving and getting better and better. The LIDAR system is establishing itself in many areas other than cartography. For example, Elon Musk would like to replace radars by a LIDAR system in Tesla cars. It could also replace security cameras to better analyze movements. And many companies are trying to integrate this system into robots, so that they are more autonomous and can better understand their environments.